Good morning, grade 9 students, and as well as to our avid listeners. You are listening to Radio Z-eskwela, Siguradong Masaya. We are here once again for another learning session in mathematics. This is your teacher on air for grade 9 mathematics, teacher 𝗚𝗵𝗶𝗀𝗺 from Nabunturan National Comprehensive High School. Let us have fun and learn from our today's topics. Be sure that you are listening attentively and follow all the directions of the activities. So before we start our discussion, make sure you are in a comfortable place and prepare the following: notebook, ball pen, and any scratch paper. After our discussion for today, you are expected to achieve the following objectives: prove the Pythagorean theorem, solve problems using Pythagorean theorem. I know some of you are just hearing this for the first time, and some of you may find it somewhat familiar. Today's discussion is focused mainly with Pythagorean theorem, which is sometimes called Pythagoras theorem. You are maybe wondering, who is Pythagoras and what is a theorem? Well, Pythagoras is a well-known Greek philosopher who proved the theorem. That is why it was named after him. In mathematics, theorem is simply a statement that has been proven to be true from other things that either known or accepted true. But the most important thing that you need to know is that the Pythagorean theorem describes an important geometric relationship between the three sides of a right triangle. Pythagorean theorem states that the square of the hypotenuse of a right triangle is equal to the sum of the squares of the legs. Before we use this theorem, let us prove this first using the two-column proof. In your notebook, draw a right triangle wherein the hypotenuse is lying down. Name the vertex of the right angle as M, while the other vertices are L and M. Name the side that connects the L and M as R. Name the side that connects M and N as S. And the hypotenuse as T. It is given that LM is equal to R and MN is equal to S as the legs. Another given is Ln is equal to T as the hypotenuse, and angle LMN is a right angle. We will prove that R squared plus S squared equals T squared. And an additional information, we will construct altitude mk as W to the hypotenuse Ln, dividing it to Lk, which is equal to U, and Kn, which is equal to C. If you look at the final drawing, you can see that we can make three right triangles, which are the triangle LMN, triangle MKN, and triangle LKM. Let us start now with our first statement. I will give you a hint. Describe triangles LMN, MKN, and LKM. When an altitude MK is drawn to the hypotenuse, what do you think is the answer? Correct! Triangle LMN is similar to triangle MKN is similar to triangle LKM. And the reason is right triangle similarity theorem. For the next statement, this is the hint. Write the proportions involving the geometric means R and S. What should be the statement? Correct! U over R equals R over T, and V over S equals S over T. And the reason is special properties of right triangles. The hint for the next statement is you need to cross-multiply the terms of the proportions in statement 2. What should be the answer? Correct! R squared equals UT and S squared equals VT. And the reason is cross multiplication property of proportions. For the next statement, the hint is you need to add S squared to both sides of R squared equals UT in statement 3. What should be the answer? Correct! R squared plus S squared equals UT plus S squared. The reason for that is addition property of equality. The next hint is substitute S squared on the right side of statement 4, using its equivalent from statement 3. What should be the answer? Correct! R squared plus S squared equals UT plus RT. R squared plus S squared equals UT plus VT. The reason for that is substitution. The next hint is factor the right side of statement 5. What could be the result? Correct! R squared plus S squared equals T quantity U plus V. The reason for that is common monomial factor. For statement 7, the hint is substitute U plus V in statement 6 by its equivalent length in the figure. What will be the result? Correct! R squared plus S squared equals C quantity C. The reason for that is segment addition postulate. And the hint for our last statement is simplify the right side of statement 7. What will be the result? Correct! R squared plus S squared equals C squared. The reason for that is product law of exponents. Now, we are able to prove the Pythagorean theorem, but we are not yet done because we will try to solve problems using the formula. So, sit back and relax. Don't go away. We will be back after the break.
The Radyo Z-Eskwela program of the Division of Davao de Oro is being brought to you by Nueda Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Archicons Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
We're back! So let us apply the Pythagorean theorem in the problem. It was stated earlier that in Pythagorean theorem, the square of the hypotenuse of a right triangle is equal to the sum of the squares of the legs. Did you get it? All right. To make it easier, let us state it this way. For a right triangle with legs A and B and hypotenuse C, A squared plus B squared equals C squared. As you can see from this definition, the Pythagorean theorem doesn't apply to all triangles. It only applies to right triangles. As you know, right triangles always include one right angle that you usually see with a square mark that helps you to identify it. But if you cannot see the mark, make sure to identify the right angle correctly because it will help you to identify the one important side of the right triangle, which is the hypotenuse. Hypotenuse is the longest side of a right triangle, and it is always the side that's opposite of the right angle. In order to use the Pythagorean theorem, you need to be able to identify the hypotenuse because that's what the variable c stands for, and the theorem c is the length of the hypotenuse side, while the other two sides of the triangle is what you call the legs. The length of each leg is represented by the variables a and b. Now, let us find out what does a squared plus b squared equals c squared really tells us. It means that we take the lengths of the two legs and square them, which means multiplying them by themselves. A squared is a times a, and b squared is b times b. If we add the two squared value together, it is equal to the total of the square of the hypotenuse, which c squared or c times c. I know it sounds so confusing to you. So let us have an example so that Pythagorean theorem makes sense. Example: you have a right triangle. The legs has the measurement of 3 and 4, while the hypotenuse measures 5. If we were to use the formula a squared plus b squared equals c squared, we need to assign this value to the variable in the formula. Let us take this way. A is equal to 3 and b is equal to 4, and since 5 is the measure of the hypotenuse, it will be the measurement of c. So, if we substitute the following values in the formula, it will become 3 squared plus 4 squared equals 5 squared. To know if it is really true, we need to simplify it. 3 squared means 3 times 3, which is equal to 9. 4 squared is 4 times 4, which is equal to 16. And 5 squared is equal to 25. Let's check to see if the Pythagorean theorem is really true. If you add the squared amount of a and b, which are 9 and 16, they really do equal to the squared amount of c, which is 25. So, what is the use of Pythagorean theorem? Pythagorean theorem is used when one of the measurement of the three sides is missing. Example: a equals 5 and b equals 12. What is the value of c? To solve this problem, we will use the formula of Pythagorean theorem, which is a squared plus b squared equals c squared. In this case, we are looking for the measurement of the hypotenuse. Substitute the given value in the formula. It will become 5 squared plus 12 squared equals c squared. Simplify by multiplying 5 and 12 by itself. 5 times 5 is 25, and 12 times 12 is 144. Just copy c squared. With this, the equation becomes 25 plus 144 equals c squared. If you add up 25 and 144, it will become 169. The equation will be 169 equals c squared. But since we are looking for the value of c, we need to find a way to eliminate the squared. To eliminate exponent 2, we need to find the square root of both sides of the equation. The square root of 169 is 13, and the exponent of c will be eliminated. Therefore, the value of c is 13. Did you get the process? Very good. Let us try another example. Given that a equals 9 and c equals 41, what is the measurement of b? In this case, we are looking for the measurement of one of the legs, which is b. How will we be able to solve it? Correct! We need to substitute the given value to the formula. A squared plus b squared equals c squared. And we will get 9 squared plus b squared equals 41 squared. Multiply 9 and 41 by itself. 9 times 9 is 81. And 41 times 41 is 1,681. The equation will become 81 plus b squared equals 1,681. Since we are looking for the value of b, we need to eliminate 81 by using addition property of equality, which means we need to add the same number with different sign on both sides of the equation. We will have 81 plus 81 plus b squared equals 1,681 plus negative 81. 81 and negative 81 will become 0. b squared will be left, while on the other side of the equation, it will become 1,600. The equation will be b squared equals 1,600. To eliminate the exponent 2 of b, find the square root of both sides. It will be the square root of 1,600 is 40. Therefore, the value of b is 40. Don't go away. We will have more of this after the break.
The Radyo Z-Eskwela program of the Division of Davao de Oro is being brought to you by 𝗓𝗺 Builders Construction and Supply Incorporated, Maverick Builders Incorporated, Mitch Construction and Supply, Archicons Architectural Construction and Supply, DB Construction and Supply, Hanaway Builders Corporation, Phoenix Corvada Tagum Gasoline Station, Master Construction and Supplies, Mackenzie Builders, GP&H Construction Incorporated, Metro Gear Construction Corporation, NEN Builders and Development Services Corporation, Max Mays Enterprises Incorporated, We Inc. Construction Company, Rangay Construction and Supply, East Sussex Enterprise, WM Construction, Councilor Boogie and Miss Marjorie Vertodazo, Icon Builders and Supply, and Apex Mining Company Incorporated.
I'm back! Let us have our last example before we end our discussion for today. Listen carefully and take note some important information as I read the problem. Alright, are you ready? A 13-feet ladder is leaning against a vertical wall. If the foot of the ladder is 5 feet from the wall, how high does the ladder reach? I repeat, a 13-feet ladder is leaning against a vertical wall. If the foot of the ladder is 5 feet from the wall, how high does the ladder reach? If you were to draw the illustration, what part of the right triangle is 13 feet? That's right! The ladder represents the measurement of the hypotenuse. How about 5 feet? Correct! The distance from the foot of the ladder and the wall represent the measurement of one of the legs of the triangle. If 5 feet measures A and 13 feet is C, what are we going to find? Very good! We are looking for B of the measurement of one of the leg. So, to solve this problem, all we need to do is to substitute the given measurement to the formula. A squared plus B squared equals C squared. And simplify until you find the value of the missing part. To start, substitute 5 to A and 13 to C. It will become 5 squared plus B squared equals 13 squared. Next is simplify 5 squared and 13 squared. 5 times 5 is 25. And 13 times 13 is 169. The equation will become 25 plus b squared equals 169. To eliminate 25 on the left side of the equation, add negative 25 to both sides of the equation. It becomes 25 plus negative 25 plus b squared equals 169 plus negative 25. And once it will be simplified, it will become b squared equals 144. Since we are looking for the value of b, we need to eliminate the exponent 2 by putting radical sign on both sides. The exponent will be eliminated and we will solve for the square root of 144, which is 12. Therefore, the measurement of the side B, or the measurement of how high does the ladder reach, is 12. Did you get the same answer? Very good. Always remember the following. Pythagorean theorem states that the square of the hypotenuse of a right triangle is equal to the sum of the squares of the legs. Pythagorean theorem only applies in right triangle. In a right triangle, the longest side is called hypotenuse, while the other two sides that form the right angle are called the legs. Lastly, Pythagorean theorem is used when one of the sides of a right triangle is missing. I hope you learned something from today's discussion. That's it for today. Once again, this is Teacher 𝗠𝗵𝗲𝗺 at your service. Thank you for listening. Bye-bye!
𝗏𝗃𝗃 Executive and Technical Working Committee. The school's Division Superintendent, 𝗗𝗵𝗲𝗃𝗀𝗺 5. Assistant Schools Division Superintendent, Dr. Romel R. Handayan. Curriculum Implementation Division OIC Chief, Dr. Arlene B. Lim. School Governance and Operations Division, Dr. Ruben J. Riponte. Program Director, Dr. Arlene B. Lim. Assistant Program Director, Noemi P. Canales. Members, Cecilia Morales, Dr. Hilda A. Opeña, Dr. Eldecris B. Calzadora, Dr. Dexter A. Siquinia, Nohara O. Pinute, Dr. Grace D. Pontillas, Dr. Renato N. Pakpakin, Dr. Andy P. Cabodok, Juanito Lapiceros, Engineer Norberto S. Manlangit, Ryan Villanueva, Jomar M. Dumupoy, Bob Daylan S. Milabat, Medard D. Apit, and Paz Eugenia Villusino. Technical Working Committee, Production and Communications, Lorely E. Quijano, Given G. Hinampas, Judiland T. U, Donna D. T. Bolifer, Mary Rose N. Resma, Riwen C. Manuel, Irene Lea C. Manguhon, and Bessie Aya N. Banyes. Social Media and Packaging Team: Christian Anhara L. Martesio, William R. Lanara, Joan T. Iscoton, Roberto S. Acusar Jr., May B. Istaniol, Richard H. Arellano, Ralph A. Tabanyag, Angelo C. Gutierrez Jr., Jade Karen R. Arais, Eliza May Garsuta, Sedi S. Caballero, and Jane S. Caballero. Sa Radyo Z-Eskwela, siguradong masaya. Right and only here at Z Radio 88.5, ang istasyong siguradong lingaw, siguradong kuyaw.